Welcome to Smart Notebook Math Tools. In this session, we will be looking at shape manipulation and shape division. First with shape manipulation. Here we can display and edit vertices of a square or a triangle. Select one of the shapes and then show and hide the vertices. Select a vertex and drag it to change its shape. Similarly for the triangle, again show and hide vertices, drag a vertex and change its shape. Next, we can display the interior angles. Again, selecting a shape, using the arrow pull down menu, and show and hide interior angles. As we rotate the shape, notice that the angles stay vertical so that they can be read easily. Selecting the arrow pull down menu, we can show and hide the vertices again. Select one vertex and drag, and as you drag the vertex around, you can see that the angles recalculate. Here's an example to show how these tools can be used. What can we say about the sum of the interior angles of a triangle? Using our irregular polygons tool, we can create a triangle, drawing 3 vertices, selecting the shape, using the arrow pull down menu, show and hide the interior angles. We can record these angles into our chart using the keyboard, entering in the values 62.3, 73.3, and 44.4. Students can calculate and sum to 180 degrees. Next, selecting the triangle shape again, using the arrow pull down menu, show and hide the vertices. Drag a vertex to change its shape. Notice that the angles recalculate, and then the students can enter the new value into the table. 47.8, 36.2, and 96 degrees. Again, summing, they find that the angles sum up to 180 degrees. They can continue this for a number of triangles and then conclude that the interior angles of a triangle sum to 180 degrees. Next, we can display side lengths. Again, selecting a shape and using the arrow pull down menu. This time, select show and hide side lengths. Selecting for vertices, showing and hiding the vertices, we can now drag a vertex and you can see that the side lengths recalculate. Also, if I rotate, you can see that the side lengths remain vertical and can be easily read. The side lengths default to a metric system and so are measured in centimeters, and we can show that using our ruler and taking a measurement. Again, let's hide the vertices and then take our measurement. And show that we have about 5.2 centimeters. You can change the side lengths for context. So here I open up my Smart Keyboard again, double click on one of the side length values, and then enter in a measurement, side measurement, let's say 24. And when I click off, notice that the other side lengths recalculate in relation to the value inputted. Now let's look at an example how this may be used. Setting up this question, if the player in the top right of the image has the puck, within what angle does he need to aim to get the puck in the net? So using our irregular polygons tool, we can create a triangle to show that situation. Select the shape and show the side lengths. Now, since the net regulation size is 6 feet, we can again input the value 6 by clicking on the side length and changing the dimensions for 6 feet. And as we click off, we have the other side lengths recalculate in relation to the 6 feet. Now the students can calculate, using the 3 side lengths, the angle required to get the puck into the net. An extension to that question, here we have right-click on the triangle and select Show and Hide Vertices. Drag the vertex where the player is to determine the location that would give the player the largest opportunity to score. So here, we can again select a triangle, use the arrow pull-down menu, show and hide the vertices, and then select that vertex and drag it and calculate for the widest angle that would give the player opportunity to score. Another example that may be set up is to solve for unknown angles and sides of triangles. So here we use our Shapes tool, and we can create a series of triangles. Our isosceles triangle, some of our special triangles, and then we could select these and show our interior angles as well as our side lengths for each of these triangles. And then we could, in setting up this question, we could hide some of these by using our pen and changing its properties. We could use a line style that is a bit thicker and select a white color. And then we can start to hide some of our angles and some of our side lengths so that the students can start to calculate for the missing sides or angles. Now we'll look at how to divide shapes in the study of fractions. So here we have a square, a rectangle, and a circle, and we can divide these into different number of sections. So in the first case, we'll divide the square. So selecting shape division and choosing 3 sections, we can divide our square into thirds, and we can separate them to show the students the different sections. A rectangle, in the same way, we could divide into quarters. And then separate these segments to show the students what the size of the pieces would be in relation to each other. And lastly, the circle. In this shape division, we could select a cut of 5 pieces, and there the students see the size of 1/5 of the circle. We can select different size. We're not limited to just a 12. So as I pick my shape, and it has to be a square, rectangle, or circle. So let's select a rectangle. And then divide this rectangle into a number of pieces. So using our shape division, before we do that, I should probably open up my keyboard. Okay, again, selecting my shape, selecting for shape division, and this time, notice that it has 12 sections that can be divided to. But in this case, we will change that to, let's say, 14 segments. And so there you see the shape divided into 14 equal pieces. And again, if I grab one of them, I can separate. Now, it's better to have these shapes filled for easy selection and grabbing. In this case, the pieces were small enough that I could grab and separate the pieces. In the next session, we will start to look at different equations and the equation editor.